All right, so we're going to finish up here with inner product spaces. So an inner product is denoted by these kind of pointy bracket things. I don't actually know what they're called. So an inner product, is going to satisfy these four criteria. And as you look at them, you're thinking, wait a minute, isn't that like a dot product? Well, actually, this came first, and the dot product is an example of an inner product. So now we're just going to do a different kind of an inner product. Okay, so we're going to do this inner product on polynomials, not on vectors. So if I'm taking the inner product between P and Q, what they're going to do is they're going to give me a set of T values to do the inner product with. And I'm going to take the polynomial P and evaluate it at the first T value and multiply it by the polynomial Q times the second T, or that same T value. I'm going to go all the way down the line. So this one here has this for T naught. See if I can write tiny enough. This is T naught, right, comma, T1, comma, T2, right? 3 T values. So here my polynomial is T squared for P, and Q is 2T. So let me just write it out here. So P, the inner product of PQ will be this polynomial P, right? I'm doing this polynomial P at the first T value. Multiplied, right here, multiplied times the second polynomial Q times that same initial T value. Plus, so we move on to the next term. So then I take this polynomial P, and I'm going to evaluate it at T1, which in this case is 0. And then I'm going to multiply it times the polynomial Q at that same second T value, plus. Then I'm going to move on to the last one, right? So I'm going to take the polynomial P at the T value of 2 and the polynomial Q at the T value of 2. All right, so now it's just a bunch of evaluation, correct? So I'm going to put negative 2 into here, so I get 4, times, put negative 2 into here, so I get negative 4 plus 1, so I get a negative 3, if I'm doing my multiplication correctly, right? Plus, so now I'm going to plug in 0, so I get 0 for this one. I'm going to put 0 into here, right, and I get 1. Plus, I'm going to put 2 into here, so I get 4, times, if I put 2 into here, I get 4 plus 1, so that's a 5. So this gives me a negative 12 plus a 0, right? Just putting that in for effect, plus 20. So that gives me a positive 8. All right, so I'm just going to do a few of them just to make sure you really understand, because it's very different, I think. So the inner product of PQ, and so now notice I've changed the T values. So here's T sub 0, T sub 1, and T sub 2. So I'm going to take the polynomial P and evaluate it at the T sub 0, which is 0, and then Q at 0, plus P at the second T value, 1, Q at 1, plus P at the last value, and there we are. Now I just get to go evaluate. So put 0 into here, I get 1, I'm sorry, 2, right? Put 0 into here, I get 1, plus put 1 into here, I get 3. Put 1 into here, I get 2. Plus, put 2 into here, I get 4. And put 2 into here, I get 4 plus 1 is 5. So 2 plus 6 plus 20, that gives me 28. All right, because I could just do one more just to really, really make sure. And I guess I really should have had these P's and Q's be bold. So I should, because they are vectors that we're doing the inner product on. So I should have made these bold, so my mistake. So again, I've changed the T values. So P of negative 1 times Q of negative 1 plus P of 0 times Q of 0 plus P at 1 times Q at 1. All right, so doing some evaluation, negative 2 plus 1, and then putting negative 1 into here, I get a negative 3 plus, this gives me a 0, and that's a negative 2 plus, that'll give me a 3 times a negative 1. So it's a negative 1 times a negative 3, so it's a positive 3 and a 0 and a negative 3. Oh my goodness, all for nothing. It's a big 0. All right, so how do we find the length of the inner product, or the norm of the vector. So the norm of the vector is going to be the square root of the inner product with itself. So to do this, I'm going to say this is going to be the square root of Q, the inner product with Q. So square root of, so I'm going to be taking, let's see what this one is. These are the three t values, right? Q at -2 times Q at -2, so I'm squaring it. And Q of 0 times Q of 0 plus Q of 2 times Q of 2. So I get the square root. So let's figure out what this is. So I'm taking Q, this is my Q right here, and I'm evaluating it at -2. So I get 4 plus 4, and I'm going to be squaring that, plus, I'm going to put in 0, so that's 0 squared. Then I'm going to put in 2, so I get 4 minus 4 squared. So that gives me the square root of 8 squared, so 8. So that's the norm. All right, I've given a lot of examples of the same thing, haven't I? I'll let you do this one. I'll just tell you that I got for PQ, the inner product of PQ, I got 4. And then this gave me root 582. So I'll let you go do those because I've done several, and then this one is just Q with itself. All right. All right, so let's continue on. I'll just keep doing the same video here. So what we like to do is if we have a subspace that doesn't approximate, so it's going to be very similar to what we've done before. So let me explain it with this example here. So P2, that's polynomials of at most degree 2. And here is a basis, and this is they're even telling us this is an orthogonal basis that's in P2, right? And I can kind of see that, right? If I thought about these are linearly independent, right? If I put them into my matrix, right, knowing that this is how we set these guys up, right? That's how I set up with the number 1. This is how I set up the t, and this is how I set up t squared, right? This is constant, the coefficients of t squared in the column, right? So this is a column vector is here. This is a column vector is here, and this is a column vector is here. Okay, so I can see this is a basis because it's linearly independent. Pivot every column, spans, pivot every row. Okay, so this is a basis for P2. So now look at this polynomial here. This polynomial is not in P2. So what I want to do is I want to find the closest thing that I can get. Doesn't that sound like the y hat? Oh, that's what we're going to be doing. We're going to be finding q hat. So we're going to be finding q hat, which is the orthogonal projection of this onto these basis vectors. So here it is. So this is going to sound very familiar, isn't it? So to find q hat, I'm going to take q and inner product with it with p naught and divide by p naught with itself and multiply by the polynomial p naught. Isn't this just like we were doing with vectors? Then the second, I'll take q, inner product with p1, divide it by the norm of p1, and then multiply it by the polynomial p1, and etc. Okay, so let's go do it. This is going to be a lot of multiplication to set up, right? So q hat. So let me just make sure we're all good on setting this up. So I'm going to be taking q, inner product with p naught. On the denominator, I'll be doing p naught with itself, and I'll multiply it by p1. And I'm just going to even write what p1 is. So multiplying it by p1, which is the number 1. Before we would multiply it by a vector, right? So here I'm going to do q with p1 divided by p1 and then times p1, which is t. And I'm going to do the same thing here, p2 with itself, and then multiply it by p2, which is t squared. Okay, so here comes the multiplication, right? So I'm going to be taking q and p naught. So here's q and here's p naught, right? And these are the three numbers that I'm evaluating it at. So the q at 0 is going to give me 4 times 1. So 4 times 1 plus. I'll be taking this here, q, at 1, which will give me 5 times a 1, plus. and I'll be taking q at 2, so that'll give me 8 plus 4 is 12 times a 1. All right, and that's all over P naught, the length of P naught, which is P naught with itself, right? So this times this, so that'll give me a 1 plus a 1 plus a 1, and it's all times the number 1 plus. Okay, on to the next one. Okay, so now I'm going to be taking Q with P1. Q with P1. So Q at 0 is 4, and then P1 at 0 is 0 plus. So Q at 1 gives me 5, and P at 1 gives me a 1 plus, and then Q at 2 gives me 12, and P1 at 2 gives me 2. So that gives me a 24. All over, and let's remind ourselves what this is. This is taking P1 with itself, right? So put in a 0 and square it, right? I'll just put that in plus, and I'm going to be taking the no, I'm not taking the square root of it because that's the norm. Plus, and then I'm going to be taking P1 at 1, and that gives me a 1 squared. And then I'm going to be putting in a 2 and squaring it. So that gives me a 4 plus a 1, that's a 5 on the denominator, right? If I simplified that out. Okay, so that's all times the t. So last one here, I'm going to be taking Q at 0, so that's a 4. And then P2 at 0, and that gives me a 0 plus. So Q at 1 gives me a 5, and now I'm going to be putting in a 1 in here, so that's times a 1 plus, and then Q at 2, we know that gives us a 12, and then P at 2, that gives me a 4. All over, and now I'm going to be evaluating this here, right? So putting in a 0, I get 0 squared plus 1 squared plus, putting in 2, I get 4 squared. Okay, and all of that is times my P2, which is t squared. Okay, so let's figure out what this number is. So here I get 4, and 5 is 9, and 12 is 21 divided by 3, so that's 7, and that's just all times 1, right? Times 1, okay, plus, we don't need that. So this gives me a 5 and a 4, 5 and a 24, so that gives me a 29 over, this is 4 and 29 over 5 times the number t, plus, let's see what it gives us here. So I get 48 plus 5, so that's 53. In here I have 16 plus 1 is 17 t squared. Okay, so this is q hat. So this is the closest polynomial to q of t equaling 4 plus t cubed. So if you graphed this on your graphing calculator and you graphed this, you would see that they are close as long as you stay close to these values. That sounds kind of like things we learned in calculus, right? So if you graph this, it's close to this as long as you're near 0, 1, and 2. All right, so let me leave this one for you to do. So I ended up getting my q hat was 1 plus t squared plus t cubed. Should I set it up for you perhaps? Just to make sure that you're really getting it. So let me just do that. So q hat, and you can turn it off if you want to. So this will be q with p naught, right? Q with p naught all over p naught with p naught, right? Times the p naught, which is 2, plus. Then I'm going to do q with p1 all over p1, inner product with p1, and then times the p1, which is 3t, plus q with p2 with itself, all times the p2, which is 4t squared, and then I'm going to do q with p3, and then the denominator p3 with itself, and then times the p3, which is negative t cubed.